So this is a video going over the Chapter 7 review packet, the free response. Now, I know it is 4 problems, and normally you would have 2 to 3, so it seems like a lot. But I did it on purpose because I want you to see how all 4 of these problems are all the exact same structure, and to get used to that structure and then just figure out the tweaks between them depending on whether they're proportions or means or one sample or two sample. So your best friend in this free response review and on the test is to have that Chapter 7 review equations sheet we filled out in class. And you have to figure out which column you're in for that particular problem. And then you're just really following down that column and using all of those equations to get what you need. Okay, so the first thing you need to do when you get a problem is to look at the situation and figure out, is it a proportion or a mean? And is it a 1 sample situation or a 2 sample situation? So here, we say, suppose the true proportion. So there's your clue that it's proportions. And we only have 1 group we're pulling from, right? It's just adults is our population. So it's 1 sample. Okay, so then you get out your handy dandy Chapter 7 review chart with all those equations. Go find the column that is 1 sample proportions. I think that's the very first column. And everything you need is going to be in that column in the order you need it. Okay, the second thing you need to do before you start diving into the problem is pull out all the numbers that are inside the initial paragraph and figure out what they are. And this one doesn't have that many numbers, but as we get further in the free response packet, there will be more. So they said a random sample of 1540 adults, so that's N. They said the true proportion of all adults. So all adults is our population, which is a lot. There's millions of adults in the world, billions of adults in the world. And then they gave us our population proportion. Notice it's P, not P hat. So by that notation, we know it's our population proportion. And they said it's the true proportion of all adults. Okay, so we got all that figured out. Now, let's kind of march through the sections. So B, what's the mean of the sampling distribution of P hat? So that is always the center of your sampling distribution. Again, the idea is that a sampling distribution is a distribution made up of all the possible samples that you could have pulled out of a population. And some of those samples will just by luck be kind of high, and some will be kind of low, and some will be right in the middle. And so we're interested in what is the middle, the center of that sampling distribution. The mean of that sampling distribution is 0.15. That the sample that is like kind of the most representative, the most average of all the possible samples that we could pull out of that population, that sample has a proportion of 0.15. 15% of the people in that sample said that they jog. Okay, so part B here is always just going to be pulling out the population proportion or mean, in this case 0.15. Okay, so then C, for the standard deviation equation, we need to check the 10% condition. And for sure, 1,540 is less than 10% of all adults. What if we multiply that by 10, you'd get 15,400. And for sure, there are more than 15,400 adults in the world, so we're good. So then go find your standard deviation equation, plug in your numbers, and get an answer. So this is always the first 2 steps in these problems. We're finding a center of our sampling distribution and a variability, a mean and a standard deviation of our sampling distribution. Then the third step is always to verify the shape. We know the center, we know the variability, now we need to verify the shape. So for proportions, it's the whole NP and then N1 minus P, making sure that that's greater than or equal to 10. We called that the large counts condition. In this case, we're plenty good, so we can verify the shape. It is approximately normal. So now we take all that information and put it into a nice, pretty picture. We know it's a normal distribution. We know the center of it, so make sure to label the center and the variability, the mean and the standard deviation. And we're interested in between 13% and 17% of people, like how many of the samples in our sampling distribution ended up between 13 and 17%. So go to your z-score formula. And in this case, because we have 2 values, I'm going to have to do the z-score formula twice. And I got 2 z-scores that are pretty symmetrical here around the center. And then I get 2 table A values. And because I'm looking for the difference in the, not different, I'm looking for the space in the middle, the area in the middle here, I'm going to subtract them. And so I get 0.9722. Okay. So I went through that in a lot of depth. I'm going to go through the other three a little bit faster. So in this case, we see that we have means, and we're talking about mean weekly screen time. So we know it's a mean situation. And again, it is one sample. We only are interested in iPhone users who share their data with Apple. There isn't a different group of people we're also interested in. Okay, so we're looking at one sample means, which is the first column on the second page. Okay, so the center of that sampling distribution should match the center of the population, 13.5. Standard deviation, what if there's 1,000 or 100 in our sample, 1,000, there are for sure more than 1,000 people who have iPhones that share their data with Apple. There is gargantuan numbers of people in reality. So I go find my appropriate equation off my equation sheet and get a standard deviation. I check my normal distribution. Again, remember, there's two ways to check that with means. One is the central limit theorem, where as long as your sample size is bigger than 30, you're good. And so that's our case here. So we know it's normal. Also, if the population, the original population distribution is normal, then the sampling distribution will also be normal. That's the other way to check. So now that we have our center, our variability, and our shape, we can draw our picture. And we know our center, we know our variability. We are interested in between 12 and 13 hours. Now, if you put 12 into your z-score formula, you end up getting a crazy small z-score. So you are, in this case, 4 standard deviations below the mean. And if you go look that up in your table A, it's actually off the chart. It's so small. So when that happens, when you're off the chart, just pick the closest one to it, which is kind of the last one, which is basically essentially 0. The reason they didn't keep the chart going is that they're just writing essentially 0. So that one is 0. And then above, we got a more, I don't know, reasonable number. So again, because we're interested in the difference between them, we subtract them. Admittedly, subtracting 0 doesn't change anything, and you get your answer. Okay. Now, the next two problems are all 2 sample situations, so there's just a lot going on in this paragraph. So let's see, we're interested in means. So it's a mean situation, and we do have 2 populations, large versus medium. Okay, and then I see a bunch of numbers in that paragraph, so I just went one by one and labeled what they are with their notation. So we have our population mean, mu of L, and mu of M. We have standard deviation of L, sigma of L, and sigma of M. We have our sample size of L and our sample size of M. And it's worth noting here too, because we're subtracting, it does matter which order you subtract in. You have to be consistent the whole way through. So I'm just taking note that it's large minus medium. That's the order that they happen to pick. And so we'll stick with that order. Okay, so pull out your chart. This would be the last column, the second column on the second page. And so for the center, you just subtract your 2 population centers and get 10. For standard deviation, you have to do all those same rules, but with both samples, both populations, both groups. So we're just going to assume that this distribution, let's not use that word, the soda machine makes what, more than 200 large cups and more than 250 medium cups. The 20 and 25 are less than 10% of all the cups it makes. And so I can now use my formula and get standard deviation. So for this one, our sample sizes are not big enough for the central limit theorem to kick in. So don't automatically use that as your way to prove normality. In this case, though, they did tell us back in the paragraph that both the large and the medium population distributions are normal. So because our original populations are normal, we can say our sampling distribution is normal. Okay, so we have a mean, we have a standard deviation, and we have a shape. So now I go down here and I don't know, just by coincidence, I ended up doing a lot of in the middle shading situations, but whatever. Okay, so we want to know if we're beyond, ooh, I made a mistake. So what's the probability the manager will consider the claim false? So if it is outside of 9.5 or 10.5 ounces, that is a broken machine. That difference is too big between them. So let me go in here and say this is, good thing I make these videos, force me to talk through it. Okay, this is the probability of being within 0.5 ounces. So I'm not going to circle that because that's not my final answer. I'm going to go 1 minus 0.9854 to get the difference on the outside. And oh shoot, I don't have my calculator or my phone. So that is something. I'll go plug it in before on my final thing. Okay, so then this answer, whatever that is your final probability, about 1.2%. Okay. Then for question 4, so same deal. Now we're dealing with proportions, and here's another note: it's proportions. So proportions. Oh, let me get back to yellow. And we're comparing 2 populations, juniors to seniors. So then you just have to figure out what all your numbers are. So we have 800 people total in the junior class, so that's the junior population size. 700 people total in the senior class, senior population size. This is a large high school. This is bigger than Shorecrest. We have the probability of being a senior who takes an AP class is 49%, and junior. So these are in the populations. We have our sample sizes for our 2 populations, and taking note that they're choosing to go junior minus senior. So we need to stick with that same order, junior minus senior. Okay. So subtract your population means. We actually know the sample size and the population size here, so we can actually officially follow our 10% rule. So 10% of the juniors is 80. 1/10 of 800 is 80. And 10% of the juniors is 70. And so if I check my sample size to my 10% of my population size, I'm good, which allows me to use my big ugly equation. And now I have a variability. So now to check that it's normal, I have to do large counts. And it's annoying for these ones because there's 4 things to check. You have to do all of these, and they all end up being bigger than 10. So we know our sampling distribution is approximately normal. And then here we finally hit an example where we are not looking between 2 values, we are looking beyond. Now, let me kind of talk through how we turned more seniors and juniors into a number. Okay, we are interested in the difference between juniors and seniors, right? We are interested in one number minus the other. Now, if they were the same proportion, if they matched, we would get a difference of 0. So 0 is like our cutoff for seniors being more or juniors being more if you go the other way. So I thought, okay, we want more seniors than juniors. So here's a way to say that with notation. P hat S should be bigger than P hat J. And then I just thought, okay, we want to make it in a junior minus senior form so we can do our math with it. So if I subtracted, I go back to my original equation. If I subtracted P of S from both sides, I would get P of J minus P of S, and then less than 0. Another way to think of it is we are interested in seniors having more than juniors, more seniors than juniors, which means we have a smaller number minus a bigger number. And in that situation, we would get something that's less than 0, a negative number. So that's a way to think about it. So 0 is our sample data point we're interested in. And if we're less than 0, that means junior minus senior is a negative, which means there's more seniors than juniors, smaller number minus bigger number. Okay, so that's probably the hardest part of that. Once you have that figured out and the picture figured out, and we have a center and a variability, do your z-score, do your table A, and because we're interested in everything below, we don't need to do any subtracting. Here is your final answer. Okay, that's it. And for the final answer on number 3, oh, actually, you know what? I'm going to pause it and then I'll go back and fill that in. I should have done that earlier. Oh, well. Okay, so I remembered I could pause and I can go grab my calculator. So if I go back to number 3, the final answer is, let's not do yellow. That's too hard to read. The final answer is 0.0146. So that's our final answer for number 3.